stop is going to be my website, tedcan.com. And you could really just kind of enjoy the show because I'm recording the whole thing. You're going to find that you're going to be following the tech assignment recordings probably more than any other recording. So yeah, just kind of get used to that thought. The only thing I ask is when you view a recording of mine online, I guess that's the only place you'd view it, make sure you hit that thumbs up icon. Smash it even, because it just makes me feel good. I don't get any money. They demonetized me because I guess I'm not cool enough. But yeah, it just, I mean, seeing a like, it's not like, I don't know, just call it like I'm going to shout out my wife here. She posts stuff up on Facebook just looking for like hundreds of likes and then gets disappointed when those don't happen. I'm happy with just one like, or I'll settle for no thumbs downs. All right, so that's fine, and no negative comments because I delete the video immediately if there's a negative comment of any kind or a thumbs down. Right? And so one semester that happened right before the final exam, and somebody put a thumbs down and a negative comment on the review video for the final exam. I was like, well, no bueno, delete. I got about 40 emails saying what happened to the video. We're like, well, you could thank the schmo who did that. I ended up putting it back up with a significant threat. So anyway, go to WCC, click on statistics. You're going to see technology assignments. You're also going to see a blank template. Your first objective is to go to the blank template and make it your own. So this is for all the tech assignments in the course. All right, so it's not just one. You see how it says tech assignment A, B, and C. It's set up for you to be a clearinghouse for all your work. All right, so what's going to happen is you're going to look to edit it. It's going to be read only. You're not going to be able to edit my file because then I can't use my file anymore. So what you do instead is you make a copy. All right, so click on File and make a copy. That's your first job. Put your own details in there, like your last name. Tech assignment stays put. The course, any variation on statistics is fine. And the semester, spring, even though it doesn't feel that way, 2020. Okay, then you hit OK, and then now you have your own file to store your information, right? And also, just do a quick copy-paste job here. Replace that title with this, and now you have your own file, all right? So don't try to edit my file. Some of you are going to try to edit my file. And what's going to happen is I try to be nice about it, but after like the 14th person sends me the same message, like I'm trying to edit the file and I can't. I'm like, well, that's because it's my file. Make a copy, for crying out loud, like I said in the video. So yeah, it can happen. If you do this tonight, or tomorrow, odds are you're going to remember. If the first time you try to do this is the day before it's due, you're probably going to forget half the stuff I'm talking about right now. All right, so just a thought. You want to kind of jump into that. All right, so we have that. So that's step one. Now you click on, in my website, tech assignments. By the way, going back to the concept of typos, I always have it. I always intend when you click on a link for it to open in a new page. If it doesn't do that, that's a typo. All right. So send me a message because I want you to always be able to come back to my my page. Oh, and by the way, if you missed it, I did mention that I record the lessons and I post them to YouTube. I do link those videos on my website. All right. So it's all in a playlist on YouTube. if you have access to that playlist, you probably don't need this, but it's all here, and even previous semesters. So if you want to get ahead, anyway, first thing you're going to do is Tech A, modeling with data. It's entirely up to you. Oh, there's a bonus tech assignment also, in case you're wondering. I haven't put the new version of Tech Assignment C up yet, but there will be 3 tech assignments before it's all over. You don't need to wait for me to assign them before you start working on them. You can work on them whenever you want. There will be assignment dates when I go over the assignment, and then there's going to be due dates. Obviously, that'll be when the assignment's due. So you can wait for the overview and then get started on it, or you could give it a look first and see if you can do it on your own. All right. So this is what we're looking at. Tech Assignment A, modeling with data. All right. So I've just walked you through pretty much all of this stuff, so you're pretty good to go. But what you have to do as a next step is go to geogebra.org. All right. So I'm going to do a little split screen action here. geogebra.org. All right. This is free online software. It's very user-friendly in some senses and very not so much in other senses. It all depends on what you're using it for. And it's very particular about the process. So you have to follow certain steps the way that they're intended to be followed. It's not very flexible, but once you kind of get that down, everything starts to work out. All right. Key statement here, be sure to save your work frequently. I'll even add into that, be sure to, every time you work on a GeoGebra assignment, make sure that you're signed in first. Because sometimes, and I've seen it all too frequently, what'll happen is people will do all their work, realize they're not signed in, sign in, and it'll wipe out all their work. Right? So just a little bit of that. If you get an error message that you can't understand, like I did it the way you said, send me a message, take a screenshot, send me a message. I'm not seeing the mistake. I'll help you out. Right? This is not supposed to be for you to be on an island figuring stuff out on your own. I'll help you. Right? So you want to go to sign in, and it'll give you the option to create an account. The best way, I think, is to link it up with something else. I linked it up with Google. I found out recently when I got the alert on Google that I have 157 accounts with the same password. So I'm about 2/3 of the way into taking care of that. Kind of sucks if you're trying to protect your identity. Anytime you could link it up with something else, especially if it's something like this where you're probably not going to use it very frequently, it's just one less password to throw out there, you know. So I'm just going to sign in. You'll create the account. I'm already signed into Google, so I'm good to go. All right. It does help if you're already signed into Google before you start that process. So just a thought. You want to go to GeoGebra Classic. All right. So if you go to the waffle, you have a bunch of different options here. One of them is GeoGebra Classic. That's the one you want. This thing kind of stays here sometimes, so if you just click anywhere, it'll go away. I have it on split screen, so all of my inputs are on the bottom of the screen. If you have it on full screen, your inputs will be on the side of the screen. It really doesn't matter. It's all the same. All right. So what we're going to do is, and so this is the assignment. It's a particular type of statistical graph. We're just going to type this data in and have it make graphs for us, and then do stuff with those graphs, right? So the issue is, and there is a spreadsheet feature on GeoGebra. It's not the easiest thing in the world to use, so I try to avoid that. We're going to type these in as ordered pairs. So instead of just trying to type a list like we did on our calculators of 0, 2, 4, 6, 8, and so on, we're going to type them in as 0, 94 in parentheses, and then work our way down the list. All right. So I'm just gonna take you through it. So when you're, especially if you're jammed up when you're trying to do it on your own, you could literally have this video going and just follow the steps as I do them. All right, so you hit open parentheses 0, comma 94. It defaults to calling it point A, so we're good. That's all we wanted. All right. So 2 comma, so open paren 2 comma 82.9. Enter. 4 comma 73.6. Same idea as the calculator. In a lot of cases, the hardest part of a question is the data entry, or at least the most involved. I won't say the hardest, because sometimes math is just hard. I'm just getting all my values in. 48.5 and 14 comma 44.4. All right. I have about like 10-ish videos of this same tech assignment up on the internet. So definitely look for the one that I post tonight. That's only because every other time I've done it, I've screwed something up at some point, or the tech failed. So hoping for the best here. All right. So what we want to do is zoom out until you can see all the plotted points in the graph. So I clicked in the graph, and then I'm just turning the wheel. If you're doing it on a tablet, just pinch and all that good stuff. So you have our coordinates. You're just repositioning it. So I have my data values. So we're going to figure out, well, not really figure out, because GeoGebra is going to do all the work, a curve that fits these data points the best. All right, so before, when I was talking about the normal curve, it was a bell-shaped curve. All right, that bell-shaped curve would fit certain data points. All right, so part of the challenge is coming up with the curve itself so that you could find the area under that curve. All right, so that's what we're doing here. We're just going to play around with different types of functions. So it's hard to see, but the keystrokes are all right here. This is exactly what you're going to type in. We're going to do a linear fit, so we're going to fit a line to this. We're going to do a parabolic fit, right? So that's quadratic or parabola. Right? And we're going to do an exponential fit. Right? So that's a really steep curve. So it starts off very shallow and then steepens out as you go out for extreme value effects. Right? So that's what all of these commands are telling us to do. So the challenge is the keystrokes. Right? You got to follow it precisely. So my first entry is going to be fit line. It brings up a drop down. You could click on it. I mean, after you type in fit, I mean, probably even after you type in FI, it'll bring up a drop down. Odds are what you want is in that drop down. I've had personal experience with this long enough to know that it generally, if it's gonna fail on you, it's probably gonna happen if you pick from the drop down. Just type the whole thing in. Just type the command in, fit line. It'll autocorrect it. Then I'm typing in the coordinates A through H in squiggly brackets. All right. So squiggly brackets. Then I need A comma B comma. You can see how this would be a pain if you had like 1,000 data points, but we don't. So E. And you can see as I include each additional value, it's tweaking that line to be more and more of a fit for the data. All right, just double checking that I accounted for all of the values. I hit the right arrow till I get outside of the last set of parentheses or a closed paren and hit enter. It locks it in and it even gives me the equation of the line, which is wonderful. All right. Then we're going to compute the R square value. Next class we'll talk about what R square means. So for now we're just going to do it. So R square. You don't have to worry about caps either way. I accidentally had them on. It's going to autocorrect it. So squiggly brackets, A comma B comma C comma D comma E. Oh, say what? Oh, cap lock. I'm sure. Thank you. Yeah. Sometimes that happens. All right. Syntax, I forgot to put something in there. And my vision is shot, so I missed that little tiny f. You do have to tell it to what you're trying to find the r square of. But again, it's not in context right now, so we wouldn't know what that meant. Comma f. But it basically just screamed at me that I forgot something, which is good. I'll do it again. So right here, it said list of points, comma, function, you moron. That's what it said to me. To you, I'm sure it'll be much more polite. I threw in the more because I should know better. Like, you're noobs. So, at least to this. All right, so next up is the fit poly. Now, I don't want to have to type in the A, B, C, D, E, F, G, H, blah, 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 all that crap again. So what I'm going to do is I'm just going to go back up to my fit line. All right, I'm going to go big screen here. See, it moves it over to the side. I'm going to hit the three dots. You'll see an option to duplicate. I'm just going to go back here and get rid of line and make it poly. Now I want to tuck in, because otherwise GeoGebra is going to decide what kind of polynomial function to fit to the data. I want it to only do a polynomial order 2, which is quadratic. You know, the ones that, like in college algebra, that you had to, you know, factor, set it equal to 0 and solve. I want that kind of polynomial, something simple. So I put in a 2 because that's what the power is going to be. So comma 2, it'll fit a parabola to it. All right. So then I hit enter. It saves that as function g. So then I need an r square for that. So I'm going to duplicate this r square. And now I just, same data points, but I want it to point to function g. You don't need the of x part. So just g, hit enter, and it gives me another r square value. One thing I can tell you about r square, regardless of what it represents, the perfect number is 1. Right? So the closer you get to that perfect number, the better off the function is going to be. All right? So the last one that we had to do is exponential. So duplicate, fit, instead of line, fit exponential. It gives you an exponential model. Duplicate one of the r squares. That's function h. So change the g to an h. And it'll give me another curve. And you can see that it looks just like the diagram. So that's your indicator. You know you did it right if your picture looks like my picture. All right, that's what it's supposed to be for. All right, you could also mess around with the rounding if you want. That's not really necessarily important in all cases. But since our rounding instructions are generally for 3 decimal places, it might be worthwhile. So the way to handle that is to click on any one of the fields that have the 3 dots and go to settings. And then you'll see in the upper right hand corner, you'll see the settings icon. I lost it. Oh, I hit the wrong thing. Settings. Oh, it's off the screen. Let me just... It's there. It's off on the side. It's just I can't get to it for some reason. There it is. That was weird. You'll see the settings, and then once you hit the little gear thing, just change 2 decimal places to 3 decimal places. All right, once you X that out or click out of there, you'll see that everything that's in decimal form is now out to 3 decimal places where appropriate. All right, so that's good. The benefit of doing all of this work to come up with the models is now we can use it to make predictions. And so that's where numbers 5 and 6 come into play. GeoGebra can be used to evaluate a function for a particular value by typing the function name and then the value that goes into it. Right? So this is, I forget what the context is. It's like temperatures or something like that. So let me see. This is time and temperature. All right? So we have a function that represents the temperature after a certain period of time. So what I want to do is I want to go into GeoGebra and decide first off which is the best function. That would be the one with the r square value closest to 1. So out of all of these options, it looks like it's the polynomial. So what I'm going to do is I'm going to turn off the others. I'm going to leave them there, but I'm going to click the circles so that they're not filled in anymore. All right, so that leaves me with the polynomial because that's the only one I want to look at. All right, so now what I want to do is just figure out, for example, in this case, f of 3, well, it may not be f, right? Because f refers to a particular function. It's just saying an example like f of something, f of x, right? So what I'm asked to do here is determine the temperature in the appropriate model at 3, for example. But in this case, we want to do it for when x is equal to 10. So my best function was the polynomial. That's the g function. So all I'm going to do here is type in g of, open parentheses, 10, and it's going to spit out what the predicted value will be. Right? A lot of applications of this, because if I want to make predictions about future events based off data collection, this is pretty much how you do it. Right? You come up with a model that represents the data, and then you plug in a number that is consistent with what your goals are, and it'll spit back what the predicted value will be. All right? You could also go the other way. If I wanted to determine, what's the time it'll take for my coffee to get down to 60 degrees, I don't know, I forget what this is, oven temperature or something. Then I can go the other way, right? I can let the g of x equal 60, right? So for that we use what's known as the numerical solver. So we type in nsolve, and then you just type in your equation. I want my g function to be equal to 60, 6, 0. If I hit enter, what it's going to do is it's going to give me the 2 times for which that'll happen. All right, it's in minutes. Oh, it's a bun temperature out of the oven, bun in the oven. All right, so I didn't really think that through. So what it's telling me is that this bun, when it's taken out of the oven, will reach a temperature of 60 degrees after 6.8 minutes. That feels right. It's on a downward trajectory. But then this one, it doesn't really feel right, because what this is saying is that the temperature is going to decrease until it gets a little bit above 40 degrees. So like winter temperature, and then it's going to start increasing in temperature again without restriction.
Put your hands on it.
Say again?
You put your hands on it.
I put my hand
No.
on it? Oh.
It's also in Celsius, so 40
Oh,
degrees.
okay, so that's another thing. Right, so that could impact things. No, I was worried that I touched chalk and then touched my face, and then I had like crap all over my face. So that's and nobody ever tells me for some reason. I guess it's funnier that way. Yeah, so I mean, you don't know what the surrounding environment is like. Maybe the person didn't just leave it on the counter after they took it out of the oven. They took it outside and then brought it back inside. So maybe that could happen. But I don't know that that data is really telling us anything like that. Right? But all your job, you're not even asked to interpret the data at this point, right? I'm just, that part's for fun at this point. Later on in the course, you'll have to make some, or draw some conclusions. But for now, we're just working on the skills, right? So that later on you can collect your own data and draw some conclusions, right? So number 7 is basically doing the same thing, but you're going to use a sine regression, so a trigonometric function. You don't have to have any experience with trigonometry to be able to carry this out, right? You're just following steps. Because trig functions are periodic, so they increase, decrease, increase, decrease in cycles, all right? So any data that's cyclical is going to follow a trig function. So it's worth investigating. The last part is the part where you can be creative. Find a data set online that can be modeled using polynomial, exponential, or sinusoidal, so sine regression fits sine. Input your data into GeoGebra and find the appropriate regression. So just what we did, find the best R-square value. Find the minimum and maximum values. This step 10 here walks you through how to do that and under what circumstances they occur. But I need you to cite your source. All right, so you have to collect the data from a website is fine, but it has to be real data. All right, so don't go to an online textbook and take like example 3 from page 22 or something like that. Don't do that. I mean, you're welcome to collect your own real data in the real world without going on the internet, But just for example, people in the past have collected stock market prices over the course of a year, for a particular stock, and made a graph out of that. Other folks have done, the Super Bowl's coming up, so the number of games played is one variable, and the number of yards rushed was another variable. Right? So you could really do anything you want. The idea is that it has to be two different variables that are that can be related to one another. All right, so that's the key ingredient. All right, so you have 2 weeks to do this. What I'll do is next class I'll carve out some time at the end of class so that if you have any questions you can ask those questions. All right, so I'll try to do that for each class coming up to the deadline. Oh yeah, that's important. So yeah, steps 12, 13, and 14 are going to tell you how to save it. But basically that's what this Google Doc is for. What you're going to do is you're going to take your GeoGebra links that you're going to get by following these steps and paste them right into this document and share this with me at tcan290@gmail. Not Yahoo, gmail.com. All right, and then you hit send. Give me editing permissions, because anybody who submits their work before the deadline, I get in there, I give it a look. If there's any feedback I can give you to make it better so that you don't lose credit, I do that. And, if you submit it 20 minutes before the deadline, I'm not doing that. But if you submit it like a week before the deadline, I'll have a chance to get in there and look at it. But I can only help you out if you give me editing permission. So don't make it read only on my end. All right. Okay, so that's it. If you have any questions, stick around. Otherwise, have a wonderful evening.